Okay, looking at another example where we're going to try and write a decimal as a fraction, but this is a very specific case when you are dealing with something that is a repeating decimal, all right? Repeating decimal, an example of it is kind of like what I have written here. If you were to take 1/3 and put it in a calculator, it would say 0.3333 until you ran out of places in the calculator for it to go, right? But it goes on forever, it never ends. That's why it's called repeating. Another way of one way of writing it is with this ellipsis after it, implying that it keeps going on. Another way is with the bar over the number or the numbers that repeat. So this is kind of the notation you're going to see, and that's what you're going to have to look at and to decipher, all right, what do I do and how do I do this? Now the technique I'm going to show you is, I'm going to admit it's a little weird. And I really don't use it most of the time, because if I need to figure out what something is, normally I can mess around with a calculator or with something else well enough to kind of figure it out on my own. But if you're in a situation where you can't, this technique does work, and it's pretty cool actually that it does work. It's pretty wild. So I'm going to show it to you. All right, so it says write this number as a fraction, and it's basically 0.8 repeating. All right, so the very first thing you do is you write out this thing. You say we're going to let n, all right, for number, equal 0. And you only write basically the part of the decimal that repeats, and then just write it out like, I don't know, write it out a couple times. We'll do this one 3 times, all right? Now the next thing you do is you're going to multiply both sides by, and this is where it gets weird, you're going to multiply both sides by a power of 10 depending upon how many digits are repeating. So if you have 1 digit repeating, you're going to multiply it by 10. If you have 2 digits repeating, you're going to multiply by 100. If you have 3 digits repeating, you're going to multiply by 1,000. You kind of getting the idea here, right? So it's basically how many digits do you have to go out past the decimal before it repeats the next iteration of it, right? And so I know that this one, you only go one digit out, and then the next one, it's the same thing again, right? So we're going to multiply both sides in this one by 10. So I'm going to go 10n is equal to 10 times 0.88 repeating. That's going to still give me 10n is equal to, and what that does when you multiply this by 10 is it moves this 8 over 1. It moves the decimal basically over. 8.88, and then we'll put another 8 there, right? Now the next thing, and this is where it's weird because it doesn't really make any sense while you do it. I'm going to subtract n from both sides, or from this equation. So I have this 10n equals 8.888, and I'm going to subtract this from it. So I'm going to subtract n equals 0.888 repeating, and 2 really wild things happen. All right. First of all, I wind up getting 9n, which is, you're kind of like, well, why do I want to know 9n? But the really wild thing that happens is that if you subtract this from this top thing, you just left with 8, because this bottom part takes care of getting rid of this. And it's kind of cool. So you get 9n equals 8, and then it's just a one-step equation. Divide both sides by 9, and then you get n is equal to 8/9. And that's really all there is to it. So it's pretty cool. And if you put 8/9 in a calculator, guess what? You will get 0.888 repeating. Let's try a couple more. All right. So 0.27 repeating. So I know that this goes out 2 digits before it repeats again, and this is also written as 0.272727, and then it just keeps going like that. So n is equal to 0.2727. We'll just write it twice like that. Okay, so we're going to multiply this by, think about this. Well, it goes 2 digits before it repeats, so we're going to multiply this by 100. So we're going to say 100n is equal to, and if you multiply this by 100, it's going to basically move the decimal point over 2 spaces. 27 0.27, and then we'll put another 27 on the end, like that. And then we're going to subtract this original n from it, like we did the other one, minus 2727. And then that really wild thing happens again, right? Where we get 99n over here, and then over here, this whole decimal falls away, and you're left with 27. And then it's just a matter of saying, all right, cool, you know, I'm gonna divide both sides by 99 now. Okay. And then I get n is equal to 27/99, and I can simplify that a little bit. I think I can divide them both by 3. So if I divide them both by, or I can divide them both by 9, actually, right? And if I divide 27 by 9, I get 3. And if I divide 99 by 9, I get 11. All right, so you get 3/11. All right, and if we take a calculator and we go 3 divided by 11, there we go. Right? That's pretty cool, isn't it?